Good morning, students. Welcome to video lecture on Artificial Intelligence and Machine Learning with Python. Subject code U18EC502A. Topic Artificial Neural Networks and Deep Neural Networks. Deep Learning. As we know earlier, Artificial Intelligence, Machine Learning. Machine Learning is a subset of Artificial Intelligence, and Deep Learning is the subset of Machine Learning. Deep learning is a subfield of machine learning, and neural networks make up the backbone of deep learning algorithms. Deep learning is a type of machine learning process that uses interconnected neurons or nodes in a layered structure that resembles the human brain. A deep learning system is self-teaching learning as it goes by filtering information through multiple hidden layers in a similar way to human brains. Without neural networks, there would be no deep learning, artificial intelligence. Sorry, artificial neural networks. A neural network is a network of neurons, ANN composed of neurons. The term artificial neural network is derived from biological neural networks that develop the structure of a human brain. A neural network is massively parallel distributed processor made up of simple processing units are called artificial neurons. It resembles the human brain in two ways. The knowledge is acquired by the network from its environment through a learning process, and synaptic connection strength among neurons are used to store the acquired knowledge. Now here you can observe the basic architecture of a artificial neural network. It consists of input layer, hidden layer, and output layer. Here, to classify some data, the data is to be applied at the input, and the classified output you will get at the output layer. The given figure illustrates the biological neuron. Here, the biological neuron consists of dendrites, cell nucleus, axon, and synapse. Human brain contains around 10 power 10 to 10 power 11 neurons. The size of cell body is around 10 to 80 micrometers, and axon diameter is around 200 nanometers. The length of a neuron is around 0.01 millimeter in brain. Biological neuron. Once again here, it consists of dendrites. The dendrites are used to collect information from other neurons. Information reaches to cell body through dendrites. Here, the dendrites will collect information from other biological neurons, and then the received signal will be applied to the nucleus. Here, at the nucleus, some processing will be done, and then after processing, uh, processing means here the summing and activation function will be done, and after the application of when the neuron fires, the some potential difference will be generated at the output of cell nucleus, and this will be passed through the axon, and the same will be forwarded to the dendrites of other neurons. That is, here the summation can be done at the cell body. Some potential difference gets generated at cell body. When the generated potential exceeds the critical threshold, that is around 10 millivolts, the neuron fires. The information transferred to the other neuron through axon. Axon of one neuron connects to dendrites of other neurons through weight or synaptic weight. Biological neuron. This is a structure of biological neuron where it collects the information from other neurons through dendrites, and the same will be applied to the synaptic weight here in this, applied to the cell body. Here some summation will be done and some activation function will be applied, and based on the threshold, the neuron fires, and if this particular threshold is above the level of given voltage, if this particular output voltage is above the level of threshold, then neuron fires, and the same will be uh, processed or forwarded to the other neurons. Now here the concept of biological neuron can be applied to the artificial neurons or artificial neural network, in that it is a perceptron. Now here n number of signals are received through, as in case of dendrites, the artificial neural network receives n number of signals at a particular neuron. Now here some summing operation will be done, and then here some activation function will be applied, and based on the threshold the neuron fires, and the same will be forwarded to the other neurons. Now here this is the uh, basic structure of artificial neural network based on the analogy of biological neuron. Now here you can observe how a particular neuron will be connected to the other neuron. Uh, Here it receives the signal. After processing at the nucleus, the same will be forwarded through axon. Here the axon connects the dendrites of other neuron through some synaptic weight, and the same process will be followed for the other neuron too. A perceptron. A perceptron is an artificial neuron. It is the simplest possible neural network. Uh, Artificial neural network incorporates the two fundamental components of biological neural nets, that is, nodes. Neurons can be considered as nodes, synapse can be considered as weight. Now here it is an artificial neural network. It is also called perceptron. Now here uh, some inputs are applied, and the inputs are multiplied with the given weights, and some summing operation will be done like this here. Uh, the summing operation, let it be some small y in is equal to 1 into wi plus w1 x1 plus w2 x2 plus up to so on wn x n. That is summation i is from 1 to n, uh, some wi xi with some bias. Now here this particular yn will be applied to the activation function to get some capital Y in output. Now the equation is as follows. perceptron. Perceptron is an algorithm for supervised learning of binary classifiers. This algorithm enables neurons to learn and process the elements in the training set one at a time. Activation function of perceptron. The activation function of perceptron can be step function, sine function, or sigmoid function, and many other activation functions are also there. Let us check. It is threshold activation function, a ReLU activation function, sigmoid activation function, hyperboloid, tangential activation function. Here, some in case of sigmoid function, let us say some x is the input and it is the sigmoid function, then the output of sigmoid function will be 1 by 1 plus e power minus x. Some other activation functions and their MATLAB uh, function names are hard limit, symmetrical hard limit, linear, saturating linear, symmetrical saturating linear, log sigmoid, hyperbolic tangent sigmoid, positive linear, and competitive. These are different activation functions. And you can observe the input-output relations and their icons. Now here, just now we discussed what is going on at a particular uh, perceptron or a artificial neural network. It is the summation is equal to uh, summation I is from 1 to n xi wi plus some bias. Now here this is the output of summation, and the summation will be applied to the activation function to get uh, the output y. Now here the function f is called activation function. Just now we discussed activation function. And if it is sigmoid, then you can observe the relation. Different network topologies. It is a single layer feed forward network in that one input layer and one output layer present. Multi-layer feed forward network. A multi-layer feed forward network consists at least a hidden layer. Now just go through the artificial neural network. It is the interconnection of artificial neurons. Now artificial neural network primarily consists of input layer, hidden layer, and output layer. As the name suggests, it accepts the inputs in several different formats provided by the programmer. The hidden layer presents between the input and output layers. It performs all the calculations to find hidden features and patterns. The input goes through a series of transformations using the hidden layer, which finally results in output that is conveyed using this layer. Uh, Feed forward back propagation algorithm, or feed forward propagation of artificial neural network. Here, uh, the signal will be propagated in the forward direction, and we have some desired signal D, and the error will be calculated between the desired signal and the output of the artificial neural network. And then for each iteration, we have to calculate uh, the error. The calculated error will be back propagated to update the weight in such a way that in the next iteration, the error will be minimized. In the next iteration, the error will be minimized. And here for weight updation, we can use least mean square algorithm or gradient descent algorithm. Why it is called feed forward and back propagation? The signal will be propagated in the forward direction and the error will be propagated in the backward direction to update the weights. It is a artificial neural network with some output. Here you can observe the output and the output will be compared with the desired signal and the error will be calculated, and in the next iteration the error will be back propagated and the weights will be updated in such a way that in the next iteration the error will be minimized. You can observe some amount of error will be minimized, and in general most of the cases the artificial neural networks will converge slowly, and around thousands of iterations are to be required to converge to a particular problem. Now just now we discussed what is back propagation, and for weight updation we can use either gradient descent algorithm or LMS algorithm. Gradient descent algorithm, the weight updation, here the error is the difference between the desired signal and predicted signal. The new weight, to minimize the error in the next iteration, the new weight is equal to old weight minus A is the learning rate and partial differentiation of error with respect to the weight. This is a weight updation process in gradient descent algorithm. And you can observe the error in first iteration, in second iteration, and in third iteration. LMS algorithm. Initially, the artificial neural network assigns some initial weights and then the output will be calculated, and based on the desired signal and predicted output, the error will be back propagated and the weights will be updated accordingly. Now here once again the weight updation process in uh, LMS algorithm. Just here I expanded the equation. Deep neural network. What is meant by deep neural network? You just observe the diagram. Here if the complexity is increased, the complexity is increased, then a simple artificial neural network can be named as deep neural network. Based on complexity, we can call artificial neural network as deep neural network. The complexity means number of input layers and output layers, number of neurons in input and output layers, and the number of uh, hidden layers. A deep neural network is an artificial neural network with multiple layers between the input and output layers. The name deep neural network evolved from the use of many more hidden layers, making it a deep neural network to learn more complex patterns. More than three layers qualify as deep learning. Convolution neural networks, CNN, are alternative to deep learning to reduce complexity, computational complexity. In convolutional neural networks, in place of in if it is a digit classification, in place of pixels, we extract features so that the complexity will be minimized. Some of the advantages and disadvantages of artificial neural networks, please refer. some deep learning algorithms and architectures, CNN convolutional neural network, recurrent neural network, long short-term memory nodes, GANs, radial basis function networks, multi-layer perceptrons, self-organizing maps, deep brief networks. Based on your application, you can choose the required algorithm and architecture. Thank you. We will meet with the next lecture.